Thank you, Emmy. This talk concerns teamwork carried out at the University of Lausanne while we were working in casework in the field of paint evidence. We realized a need of data, a need of background information, helping us in assessing the evidential value of a situation where we find undistinguishable questionnaire and non-sample, so for typical comparative analysis. What I would like to share with you today is an approach based for the interpretation of mass-produced items with a particular application of paint, based on objective data, which will be useful for us to have our personal opinion for an interpretation of a case. The current situation that I'm sure you have in your laboratory during this kind of comparative analysis is the following. I mean, the evidence and its deputative source are undistinguishable after analysis. So the rising question is, what is the evidential value of that? To try to answer to this question, we consider important, we think that it's very important to obtain information about the rarity, where it depends on the type of the commonness of the occurrence of observed features in our samples. When we have a trace and a noun sample, we observe some characteristics. So we want to know how they are rare in a given and relevant population. It's why we decided to undertake two population study, and then we also applied, and I show you this application for 2 cases submitted to our laboratory. Let me introduce the first case. It was a burglary case, a typical case when a door was forced with a crowbar. They entered, they just stole an important sum of money. During the crime scene investigation, they couldn't find fingerprints or DNA or usually important traces for the resolution of this case. And in any case, thanks to regular investigation, they could they could find a suspect, and they found a red crowbar with some traces. You can see the blade of this crowbar with some blue, pink, and white traces sticking on the blade of this crowbar. They also realized that the forced door was a pink and blue 2-layer paint system. So they decided to undertake comparative analysis, and we were asked the following question, meaning, do such traces come from the putative source? Of course, comparative analysis. This was the analytical sequence we followed. We started with optical methods, and with optical methods, given that you have seen before in the picture, the quality of the trace is not good. It was quite poor in the sense that we hadn't the chance to have multi-layered fragments. It's why we just undertook stereo microscopy, realizing that we had just mares. And very important, we applied Ftir spectroscopy and Raman spectroscopy for this analysis. I just show you here the Ftir results. We can see that the spectra are undistinguishable. I don't show you the pink paint just because they are really the same type of spectra and also undistinguishable between known and questioned. Here we have for the blue paint the Raman analysis using an argon laser. We can see that we have the same bands. Practically, we have in the there I cannot show them. Okay, it's too far. In the left side of the spectra, we have the major bands we could have attributed to a very common pigment, which is pigment blue 15, as phthalocyanin. We have just the 2 bands on the right is rutile. So we could really detect the pigment and the extender using this technique. And of course, with Ftir, the binder type and the talc extender. However, after the comparative analysis, this could be really a typical conclusion that we can encounter in a report. The blue and pink traces resulted to be indistinguishable from the blue and pink two-layer reference paint coming from the faucet door. So what? We go further, and we want to know what is the evidential value of this knot on the indifferentiation. Before trying to answer this question, I suggest you to introduce the second case, which was also a typical case we can encounter in our lab. So it was an hit-and-run accident. A guy was just driving in the city of Geneva, enjoying the sun, the lake, etc. And another driver came in the back and hit him in the back. Of course, he didn't stop, he went away. However, he could note the plate number, he called the police called the suspect. Of course, he denied the event. So evidence was searched on the vehicle, and it was observed that on the damaged car, which was a gray metallic Honda Legend, some red non-metallic traces were observed. And of course, the suspected car was a red non-metallic for Fiesta, so they supplied us the samples for comparative analysis. We had the same type of mission to establish if they have a common source. And the sequence, analytical sequence, was the same as the previous case. I just want to show you the quality of the trace. The most part of the traces we have in the laboratory are not, unfortunately, multi-layer fragment, but it's really something like that. They are just a smear. In this case, it was really very difficult to isolate the trace from its support. I'm sure you know this aspect of paint analysis. And also the quantity of material was not very abundant in this case. However, we could do, of course, the FTIR. We can see from test spectra that we have the contribution for the clear coat. We were not able to isolate the red trace from its supports. However, we could attribute with the black arrow the clear coat. Otherwise, we can see that we have the same absorption, infrared absorption bands in this spectrum. With the Raman, we could also obtain two indistinguishable spectra. We could detect that this also very common pigment, which is the pigment red 254. So again, after that, we have the conclusion. After a comparative analysis, the red traces is resulted to be indistinguishable from the reference paint. And again, what does it mean? What is the evidential value? Confronted to this problem, another question arises. And typically, we wanted to know of these characteristics, meaning being red non-metallic, having an alkyd orthophthalic binder type, pigment red 254. And for the other case, it was also alkyd orthophthalic binder type with talc, with pigment blue 15 and the rutile. What is the occurrence of this observed profile in a relevant population? Or what is the chance to observe these characteristics just by chance? So our approach, again, I stress on this fact that we want to undertake a study to try to get some objective answer for the interpretation of this type of case. And particularly for paint, we focused on the exploitation. We wanted to determine what is the rarity of physical and chemical feature. Very important, the basic one for paint, which are the color, binder type, pigments, and extenders. So we realized a population study which concerned the observation of the variations, were important, of these different features. So it's really a concept of polymorphism, of a set of reference sample, also very important, being randomly selected, because we want they are representative of our environment, of our population of interest. Let's go back to the first case. What we did for architectural paint. we just got our samples. We asked police officers when they are called for a burglary scene, and when they observed a forced door, we just asked to scratch just a little bit of the support and of the paint width. We could do that, given that there is a damage. They had to change all the door, all the windows, so we had no problem to get. They really, it was really a good collaboration. We were really happy to collaborate with police to obtain our data. Again, the criterion is random. Burglars don't choose their targets according to the color and the chemical composition of the house. So what we wanted was something representative of the population. We got data for different type of entries. We had doors, front and back windows, glass door, because of course there are many ways to enter a house. We consider everything. And the painted surface could be wood or metallic, depending if it was a window or a door and so on. I also wanted to say that it was there were many targets. There were villa, dwelling, houses, public houses, a garage, factories. Also, it was a wide population also in the target. Now, the first thing we observed was, of course, the most important features, the color. We can see that the most important color in household is white. Is confirmed in different study. But for this case, we wanted to know what is the occurrence of blue in our population, because our traces were blue in this case. So we saw that there were only seven samples. This was just an indication saying that the blue color is not so common to paint door in our population. However, we can take the chance that, given that we have the sample of this population, that we can also go further, in the sense that we could also do underclasses and exploit more. We did it with the Ftir spectroscopy, and then we have on the right all the 7 spectra of this blue sample belonging to our population. We can see that the Ftir spectrum of the blue traces, there is only one that could, excuse me the term, I don't like it, but anyway, could match to a sample belonging of the population. And you can also see that could be differentiated if you want, because the talc compound is really very important. So for a semi-quantitative comparison, it can be clear. Anyway, we can consider that it match. I want to let you careful on the name of this corresponding sample, which is FR05. They were also analyzed by Raman, and we can see that the FR05 gave fluorescence and didn't give the same spectrum as the one observed for the trace. If we compare the spectrum of the trace with these 7 of the population, we can see that, of course, the pigment B blue it's common. It was observed in 2 samples, and however, in this spectra, we can see that there are some bands, additional bands, that allow to differentiate. Maybe sometime we can use this additional band to identify a compound. The most part of the time is not possible. However, they are useful for discrimination. With the green arrow, we can see that the most matching spectrum has an additional bands that allow us to potentially exclude them. What just we wanted to show with that, it was that even for mass-produced items, we couldn't find a same configuration as the one observed in our case, in this population. For the second case, we did pretty well the same. However, this time we worked with car body shops. We went in car body shops and we asked these people when a damaged car came in their garage and they observed a damage. When they observed a transfer of material on this body of the car, they just cut out the damaged part and transmit it to our laboratory. Again, in any case, it's a part that should be thrown away, so they just put in a bag and send in our laboratory. We collected 154 samples, and again, the criterion is random. We want it's representative of our population. By the way, we have the color distribution. Again, is the first feature we observe. We compare test data with the statistics of vehicle in Switzerland, and we could detect that for 2003 and 2006, the distribution of the main color, meaning the gray, the red, and the blue. The other one, there were some variation. However, for the main color, it represents, if you want, the Swiss distribution. In any case, for our case, we can see that the red portion is what we are looking for in our case, because we had the red traces, is 22%, so common. We can say it's common. However, we have said that we had a non-metallic paint. So we also differentiate. I suggest you to see this one, the red metallic from the non-red metallic. We can only see that only one portion of we had only one portion of the red, which was 11 sample on the 154, which represented the 7%, was red non-metallic. Again, among a common class, we had a subclass allowing to reduce this population. And for reason of time, I just don't show you all the spectra, but we couldn't find undistinguishable Ftir spectra in our base. So in this case, Ftir was really the key, the most important technique in terms of discrimination, and we could test it. And it was not the case for Raman, because many of these 11, there was a 1/2 which were fluorescent, and the other had this very common pigment red 254. But with the Ftir, we could add the different classes and really distinguish all the 11. Or in any case, I don't remember if I could distinguish all the 11. In any case, we couldn't find the same configuration of bands we observed in our case. Coming to the conclusion and some discussion, I just remind that the aim was to obtain some objective approach for the interpretation of a very common mass-produced item. The collection of data on the rarity of physical and chemical features of a reference population was undertaken for test 2 population of household and automotive in order to get some information about polymorphism. And then I also would like to take the opportunity to confirm that spectroscopic methods are really great methods for the classification, to do this kind of study, particularly for paint, just for classification. You perfectly know, also with other area like fibers, there are very good database that allow us to really classify. And also with Raman spectroscopy, what is interesting, I should say that you have the same principle of classification of Ftir. You have more common compounds you can observe, for example, more common pigments, but however, there is this presence of additional bands which allow us to do subclasses, and this is an important factor. Before coming to the conclusion of the case, I also wanted to take the opportunity, of course, to say that these studies don't want to say that the sample we observe are unique. The idea is to say that it is really very unlikely to see the same characteristic, particularly considering with a mass-produced items in a given population in our environment. It's also true that they are local studies. However, if we do an expertise, it should be in our context. It should be integrated in the context where we work, when we live. So it's logical that these studies should be local. There are, of course, in industry a lot of changes. However, the aim is to see that we live in an environment that are really very wide, we have many differentiation. At this study, I think they are a good indicator, so it's not absolute. I don't take detailed and exact data from that. It's really an indication of this variation in the population that we really need to do our conclusion, at least in my opinion. In For both cases, we could say that the consideration of the paint properties, less color, infrared and Raman profiles, demonstrated the high rarity of the frequency of distribution of the observed features. For both cases, our opinion, what we wrote in the report, was that the rarity of such profiles strongly support a common origin. And this typical sentences statement that we put in reports. However, I just take the opportunity to tell you that in our reports, in the footnotes, we indicate a scale of possible conclusion going for common origin, strongly support, non-conclusive, and exclusion, so the non-scientists can have an idea of what does it mean, strongly support. I think it's a convivial way to transmit our information. Otherwise, for me, it's all. I thank you for your attention, and I'll be ready later for your question. Thank you.